Flow measurement loops making use of differential pressure measure volumetric flow. If mass flow measurement is needed, the instrument system must also measure fluid pressure and temperature. Here we see a magnetic flow meter. Magnetic flow meters measure volumetric flow. Two coils generate a magnetic field. As a conductive fluid flows through the metering tube, a potential is produced in the fluid. Electrodes projecting through the metering tube's lining sense the induced voltage. Since the magnetic field is constant, the voltage is directly proportional to the fluid's velocity and thus its volumetric flow. This flow meter is called a vortex shedder. It consists of a blunt, flat-faced body called a shedder, a sensor, and a transmitter. As fluid flows past the shedder, it swirls, causing alternating vortices downstream. The sensor measures the frequency of the vortices. This measurement, processed and amplified by the transmitter, is proportional to the fluid velocity and flow. Here we see an axial turbine flow meter. In this design, a turbine rotor is placed in the fluid flow path. Fluid passing through the unit causes the rotor to turn with a velocity proportional to the fluid's flow rate. The electrical pulse generated in a pickup coil is proportional to the speed of the rotor and therefore indicative of fluid flow. We have seen only a few of the many ways that flow is measured in industrial instrumentation and control systems. The information you have learned about pressure, level, temperature, and flow, together with the physical principles behind their measurement, will contribute to your understanding of the processes and systems in your facility. Remember, however, that designs and operating principles differ, so always follow the manufacturer's instructions and your facility's guidelines before working on any process system.